ready to go on a call. Go on a call. I'm emceeing those. Is everything okay? Yeah.
Who is the 803-270-5804 number?
The meeting go okay?
That's mine. Samuel
Okay.
Ford.
And who's the 919 number?
I'll do it as soon as I'm up. I'm by.
Dexter Matthews.
Okay, great. Thank you.
Yeah.
So I see we have 10:30 if we want to go ahead and kick things off. Anna, are you ready?
Wait 1 second. Let me switch the slide deck really fast. Sorry.
Okay. As Allie's working on having the slide deck load for us, I'll take this moment to just thank everybody for this just continued conversation, continued commitment to this process about scrap tires in South Carolina. I think we've already had some great conversation in our previous meetings. This is meeting 4 from where we started this fall. Yeah, and a great feature of this group is how we bring together so many different voices from industry, from county government, from the recycling businesses that we have. And so I'm looking forward to today's conversation as well. We'll give Allie just a moment to catch up. And while she does that,
Christy,
yep.
it's Stephanie. I'm going to go ahead and mute everyone because we've got some background noise. So please unmute when you're want to talk.
Yeah, that's a great point there, Stephanie. To help with this meeting, especially since we have such a large group that are joining us virtually, we want to make sure we're able to kind of control that background noise. Our tech team is behind the scenes with Stephanie and Catherine Yon. They may mute you if your mic is unmuted. You can always unmute yourself. We encourage you to raise your hand. We want this to be really participatory, so raise your hand and use the chat throughout the meeting. And if you do get muted and you want to speak up, all you can do is unmute again. If you've joined us by phone, you can unmute by dialing *6, or you can be using the mute feature on your phone. So *6 is the way to kind of unmute yourself in the Teams way if your phone was not muted. I think that helps us with a little bit of ground rules. Even I can get muted. So
Sorry.
that's all right.
I can't share my PowerPoint.
Okay.
It says it's been disabled.
I didn't do it.
I think
Well,
that was me. Hold on.
Thanks to everybody for working with us.
Who is it that's trying to present?
Allison.
Okay. Try it now if you would.
There we go. And no, we're ready to get things started. So Richard, you want to kick us off?
I sure do. Good morning, everyone. I'm Richard Chesley. I'm the manager of the Office of Solid Waste Reduction and Recycling. To echo Christy's comments, thank you so much for taking time to be part of this coalition and this meeting today. We believe the meetings are going very well, and we're excited that we moved forward very quickly on overall funding issues about what to do or not do and options we can look at, etc. And that's being looked at now, led by Association of Counties and some other stakeholders. We shift gears, no pun intended. We shift gears today to talk about markets, beginning with, but not exclusively, but beginning with rubberized asphalt for paving. We have 3 key speakers just to tell us what the situation is nationally and with markets, etc., who's doing what, and can it be done here in South Carolina. We'll go in order here. Doug Carlson will be our first speaker. He's been with Liberty Tire Recycling for 12 years and is the Vice President of Asphalt Products. Doug, if you're there, feel free to add anything else that you would like, and I appreciate you being here. Thank you. I turn it over to you.
All right, very good. Thank you very much, Richard. Can you hear me?
I can.
All right, very good. Well, I do have some slides. I see that we're pretty well covered on all aspects of rubberized asphalt today. So let me just go through some slides to provide some key points. Is the slide deck visible now?
There we go.
Okay, very good. All right, appreciate your patience as we get set up here. My doesn't seem to be responding to advance the slides.
We are actually seeing the edit screen of your
Right.
PowerPoint. Yeah.
I can't get any response from my computer. Well, let's say
Doug, this is Red Clark. Whoever the host is for this meeting has disabled the slide sharing.
We actually only disabled it for attendees. Presenters such as Doug are able to present.
Yeah, for some reason I think my computer's trying to read a second monitor that's no longer attached to my computer, so it's in presenter mode of some kind. But let me just go to some key facts here. I can't even advance the slides at all.
Doug, forgive me, but Ashley, if we or Allie, if we turn it on for everybody, can Doug use it?
I'm not controlling the power.
This has nothing to do with us. This is
Okay.
Doug's. This is
Okay.
Doug's
problem. Yes, it's my problem.
Sorry. Just trying to help.
Let me just stop sharing and try to reshare. See if that helps me out.
We're cheering for you, Doug. We're here for you.
All right, super. All right. It's just I'm not getting any response from the PowerPoint. So I've got some major malfunction with my computer. I apologize. But let me just talk about some key points. A little bit about Liberty Tire Recycling, founded in the year 2000. We have over 2,600 employees now, with 28 facilities, collection facilities, and 24 remediation facilities. We collect about 190 million tires across North America, and we've cleaned up over 150 scrap tire piles around the country. So we've been growing, and we've been working with rubber modified asphalt, and decided to get into the business directly with some newer technologies. Many of you know that rubberized asphalt's been around since the 50s. It started out in the city of Phoenix. Charles McDonald, a city engineer, he decided to mix tire rubber and asphalt together. He made some pothole patches that performed extremely well, and he ended up collaborating with industry to figure out how to make large quantities of the material and spread the material across the entire roadway. So over time, that evolved into a what's called the wet process. So they take scrap tire rubber and mix it in with the asphalt liquid and cook it for about an hour at 300 to 350 degrees Fahrenheit. And they're trying to get that rubber particle to absorb the binder and the oils in the asphalt and swell. And it builds a lot of viscosity, gets really super thick. So it does require a lot of equipment investment to handle this highly modified rubberized asphalt liquid. So mobile blend plants evolved, and they're excellent. They work really well. However, they're very expensive, and it's hard to grow the rubberized asphalt business in an area where blenders don't exist. So even though these are mobile blenders, they're still very expensive to move. It could cost up to $50,000 a year, per project, $50,000 per project to move this equipment around. So very, very expensive. Some asphalt refineries and asphalt terminals have developed a rubberized asphalt binder that they supply. But then there's always the liquid storage and handling issues related to that rubber modified asphalt that make it very difficult to use in new areas. So I'm excited to say that Liberty has developed a reacted rubber particle technology that capitalizes on all of the technology that was provided by the wet process. And we do essentially the same thing. We take rubber, heat it up to about 300 degrees, mix it with an asphalt extender oil so that the oil gets absorbed into the rubber and the rubber swells. And then we end up, though, with a dry powder at the end of the process. So we can send a dry powder to the asphalt mix plant and mix it into the asphalt mixture directly. So in just last year, actually this year in June, we installed our Smart Mix equipment. We call it Smart Mix. We installed that in Jackson, Georgia, just south of Atlanta. So we're happy to be able to reach the Southeast market with this new rubber technology. I do want to point out the whole process. We could do anything with rubber. We have coated rubber with other materials like latex. We've added polymers to rubber and coated them. We've even used the old South Carolina spec, the trans polyactamomer material, and we coated rubber with that. So we can make just about anything that anybody wants with rubber and additives that are good for asphalt. So just avoiding all the slides, I'd say what was really intriguing about this treated rubber technology is we were able to do a pilot project in Michigan in 2015. It performed exceptionally well, and it convinced Liberty to invest in the equipment and start making this treated rubber powder to supply to the market nationwide across North America. The other really nice feature about this treated rubber technology that's added at the mix plant, any job can, we can put rubber into any asphalt job of any size. So formerly with the wet process and all that equipment requirements, they had to make big batches of treated or rubberized asphalt liquid, and that was not cost effective. That was not cost effective to treat small projects like parking lots. So this newer technology can be used in small volume projects like parking lots and residential overlays, and it makes it very cost effective. Lastly, we are working with cities and counties around the country to develop a new way to specify rubber modified asphalt. In the asphalt industry at large, there's a development of what is called the balanced mix design. So in this design process, they're actually testing the finished mix that's placed on the roadway. Currently, the way we test and approve mixtures is we test each component separately. We test the asphalt for performance. We test the aggregate in many ways for performance. And we have a recipe to put it all together, but we don't end up testing the finished mix. So with this balanced mix design concept, we are testing the finished mix at the mix plant, and it's just checking the mix for resistance to cracking and checking the mix for resistance to rutting. So these two primary ways that pavements fail are cracking and rutting. And so this spec allows the mix producer to check the finished mix on site for those two major properties, crack resistance and rut resistance. And so just like Charles McDonald back in the 1960s, a city engineer that started the whole rubber modified asphalt industry nationwide, we're looking to reinvigorate cities and counties and agencies at the local level to try this balanced mix design concept. And it provides a cost-effective way to put rubber into asphalt at the local level. So I know that's about all I've got to say. I appreciate your patience with my technical problems, but that wraps up what I had to talk about, and I look forward to seeing what everybody else will be talking about today.
Thank you, Doug. Allie, everyone, Christy, do we want to take some questions now or wait till the end? I'm sorry, I don't have the agenda in front of me.
We're happy to take some questions. Again, I want to encourage anybody you can raise your hand or use the chat if you want to reach out with a question now. And we can certainly have a larger conversation going forward as well. I see Nicholas has his hand raised.
Hi there. Thank you, Doug. I appreciate your presentation. And no worries on the slides. We completely understand. While we're having a lot of conversations with folks in the administration and other industry folks regarding asphalt and legislation like the Inflation Reduction Act, there's a big emphasis on materials and the environmental benefits of the generation of materials, and for the government to be sourcing materials that are more carbon efficient, specifically low embodied carbon material. Do you all have any data in regards to the manufacturing of things like the Smart Mix asphalt and how that could compare to traditional methods of asphalt generation? And does that kind of factor in any carbon offsets of using a recycled tire?
Yeah, good question. Yeah, we do have some data. I don't have it in this presentation or available at the moment, but the National Asphalt Paving Association has developed the life cycle cost information related to recycled content materials, including tire rubber, and their estimated carbon footprint. So the benefits of recycling can be seen in terms of carbon reduction. I don't have it for asphalt specifically, but for example, in our molded and extruded product lines, where we use tire rubber in place of virgin rubber or polymers, there's an estimated 318 pounds of carbon reduced for every 4 tires that we recycle into molded and extruded products. So I would say it's going to be a similar value in asphalt if we're replacing SBS virgin polymers in asphalt modification.
Yeah, I think that's helpful. And I think with state DOTs looking to access those IRA funds, they're going to have to talk to the administration about, how these materials would qualify, right, to access the funds for offsetting the costs. Like you were saying too, the investment on the front end might be a little high, but with the IRA, they're looking to offset that with the federal funds. So I think that kind of data, if we can get industry, to come together and get solid data for that so that the state DOTs have access to that, that might also be helpful for them to, again, offset those costs.
Yes.
So I do see a few more hands, but I do want to make sure we're getting to Susan Dukes and Dr. Red Clark in a moment as well. Woody, do you have a quick question? And then we'll check in with Red and see if we can move back to our presenters.
Yes, thank you, Christy. Doug, I just wanted to know, I know there's a couple of webinars will be taking place, and one on the 8th and one on the 13th. And I believe you'll be presenting in one of those webinars as well, or both of them?
Yes.
Okay, great. So that'll be another opportunity to hear about the products.
Yeah, indeed. And perhaps by Wednesday, I could get that carbon data for rubber modified asphalt and throw that in there so that we can see that fact.
Excellent. Thank you.
Uh-huh.
Red, did you have a quick question? I know we want to get back to the agenda and get to your slides as well.
I have some data on carbon emissions, carbon reduction with asphalt during my presentation. We'll cover it in a few minutes. Perfect.
Thanks so much. Richard?
Yeah, real quick, Christy, Doug, and it will be for all the speakers, but a brief answer is fine. With the changing, I guess, material in tires, etc. The new technology, tires are, last longer, different material, all that. The short version, how's that going to play out with all the research you guys are doing, etc., with scrap tires and getting it to be where it's a higher end product to use?
Sure. Yeah. So with the general premise with tire chemistry, obviously tire recyclers cannot control the compounds and components that the tire manufacturers put into the tires. We just chop them up and size reduce them. But in terms of asphalt mixtures, the rubber particulate is more of a mechanical modification than a chemical modification. So it's providing a mechanical benefit in the crack resistance. So each little rubber particle stops cracks as they propagate or try to propagate inside the mix. So it's I'm not too worried about the tire chemistry in the dry process or the balanced mix design concept.
Thank you.
Mm-hmm.
Christy, we want to go to Susan?
Let's do it, Richard.
Okay,
Susan,
yeah, Susan, are you ready? Yeah.
Hi guys, we're here. I actually have Cliff Selkinghouse here as well. So he did not have to go to Savannah, Georgia. So we're both going to tackle our slide deck for you guys. And I think our slide deck will actually move in nice with what's to come with Dr. Redmond's, and then also what Doug was talking about as well. So we're going to talk to you guys a little bit about the GTR processes, South Carolina DOT's current specifications, some of the past GTR projects that we've worked on, and then Cliff is going to take over and talk about more of the resurgence of SAMI, which is a process that we have used in the past and what we're looking at doing now, EPD information and how they're affecting us, and then some advantages and disadvantages of GTR that we've, I guess, kind of come up with for the asphalt industry. And then what South Carolina Department of Transportation's next avenues and steps are for using GTR in asphalt. So just to give you a little information, can you guys see the slides? I think they're moving.
Yes, we've got GTR
okay, you guys
grounding
got
process.
All right, and I'll let you guys know when to go forward. Cliff has been with the South Carolina Department of Transportation for 28 years, and he is the asphalt materials manager. And I'm Susan. Sometimes you'll hear Snyder or Dukes. COVID kind of put the name change process on the back burner. So if you hear either of those, it's me. And I am the asphalt materials lab testing supervisor for South Carolina DOT. I have 10 years total working experience with asphalt and about 3.5 with the DOT, just for some background information. So with the GTR grinding process, as Doug was saying earlier, you do have to grind them up to be able to use them in the roadways. So you have to remove the sidewalls, the steel belting and fibers, and then the waste tires are processed and ground, usually to about a -30 mesh or finer. The finer the GTR is, the more uniformly it is distributed throughout the asphalt binder, which will give it a more consistent performance. However, the downside of the smaller grind is that it's more expensive. There are two types, the wet and the dry process, and we'll go ahead and hop into the wet process really fast. GTR is sheared. Oh, it changed our slides. GTR is sheared or blended and blended along with the paving grade binder, which here in South Carolina, we use a 6422 to get it to a 7622. And this will happen in a mixing tank for the wet process. Usually about a minimum of 60 minutes of blending is needed for the GTR to be activated, which means that it absorbs the light fractions of the asphalt into the rubber, and swelling will occur along with increased viscosity of the binder when this happens. GTR is added up to 20% by weight of the asphalt binder, and then depending on, well, it'll depend on the final grade of asphalt that's required. So if we're only wanting to get up to a 70, you're going to use less GTR than if you want to get up to a 76, and more if you want to get up higher. Higher percentages require more heating and blend time. And then this is usually, well, here in South Carolina, we terminally blend. It's what we do with our anti-strips as well. So we have not done this on site, but it could be done. We prefer the terminal blending method to take that step out from the contracting side.
Just to make sure it's consistent and it's a consistent product is being delivered.
Yep. So with the dry process, there's two methods. You have the aggregate replacement, which is where you actually take out some aggregate and then put larger chunks of GTR in it. This process is not typically advised just because it swells, and when it swells, it kind of raises itself up to the top of the asphalt. You also have the mixture modifier, which is where 10% of the GTR by weight of the binder is used, and then the GTR is grinded and blended into the asphalt mix to fill in the void structure. And the rubber particles are generally not quite as fine as the wet process, but you can still use this more often on gap or open graded asphalt mixtures. And gap graded is when you have a lot of smaller fines and then you have bigger aggregate, and then there's nothing really in the middle for the aggregate size. And then open graded asphalt mixtures allows the water to drain down through the asphalt pavement and then be released off the road. And all right, so some of the current supplemental specification, I don't want to read all of this to you guys, but we did provide the link for you guys to hop on and read as well. Some of the main things that's noted in here is that we'll need a dedicated storage tank for a terminally blended GTR binder at the asphalt plant. And it's going to have to provide continuous stirring, and the tank must be heated and capable of maintaining temperature somewhere between 300 to 350 degrees Fahrenheit for that GTR binder. The next slide that we have just kind of points out what we look for our GTR rubber. So we do actually already have something in place that contractors could use to do GTR mixes. The biggest things that people always ask, we highlighted in red, and it's usually a minimum of 7% by weight of the asphalt binder of GTR that we would use to get it to a 76. And then we prefer or require a 30 mesh GTR rubber. So, and then before I hand it over to Cliff and just talk really fast about some of the past projects that we've done, and we kind of dug deep on these. So the first project that we ever did with GTR was back in 1992 in Greenville, and we used the dry process. And this was more of the aggregate replacement. The particles were really large, and we did not get good results on this at all. They did swell and move to the top of the road. 1993 to 95, we did a few roads wet process wise, and these weren't very heavily trafficked roadways. So we had comparable results to using conventional hot mix asphalt. But since we didn't have the heavy traffic loads, we didn't really see the extra benefit of using the GTR in these roads. 2003 to 2004, another couple of projects. This was in hand with the ARTS program, which is the Asphalt Rubber Technology Services program. We decided to use SAMI first, and then we used a GTR modified asphalt on top of the SAMI. And we're going to get into SAMI. Cliff is going to, after this slide, talk to you guys about that. But we did this as a wet process as well, and we actually had very good cracking performance with this, which is why we're looking at bringing this back. In 2011 to 2012, we have another project that was GTR modified, and we used dense graded, and we also did the 12.5 millimeter OGFC. This one is still in place, but it is raveling, and these are the roads that will end up being milled and then replaced. 2012, we did one in Richland County off of I-20, and this one we were doing a comparison of 3 different sections of OGFC. We did a wet process GTR for one section, and then we did hot SBS for the second section, and then a warm mix SBS section. We did see and do still see raveling, and some of these spots have been patched already. The next to last one was a frontage road in Lexington, and we used the GTR wet process for this one, and it is still in place. And then the last one that we've done back in 2020 was a GTR dry process using 9.5 millimeter OGFC, and it's still in place as well. So we do have our hands, I guess, in GTR. But I am going to go ahead and turn this over to Cliff so he can tell you about SAMI, and then the EPDs and what we're experiencing with that, advantages, disadvantages, and then our next steps.
All right, thanks, Susan. Moving on to into the SAMI. Next slide, please. Thank you. The mention of the word SAMI, which stands for stress absorbing membrane interlayer, which is basically something that's used to mitigate cracking on roads that are in poor condition that need to be reconstructed. Our reconstruction process that we currently use and have been using for around 10 years now is called CMRB, which is cement modified recycled base. And we currently are recently run into an issue in the last 2 to 3 years of obtaining enough Portland cement, which is necessary to perform the reclamation process on several, I'd say, numerous SCDOT contracts right now that the contractors already are working on, but we're being held up because of a shortage or lack of Portland cement basically throughout the country right now is having that issue. So as a result, the DOT has to look at alternative methods on Pacific roads that are typically in fair to poor condition. If they're in extremely poor condition, to the point where we have to do full depth reclamation, we have to do full depth repairs between 10 and 14 inches usually in depth, then we have no choice but to rebuild them with complete
asphalt structure or CMRB or other alternative methods. So we're looking at this as a potential game changer to bring the rubber modified SAMI back into South Carolina. So if the road's relatively still holding up and is in fair condition, we can possibly flip some of these current projects over to using a SAMI layer along with a dense graded mix on top. So again, we got this. We're looking at this. We're working alongside of Sergi and Mary. Mary's on, I think, on the line today. I'm not sure Sergi's on or not, about revisiting this spec. We updated it since they've been looking at it. I guess we did it back in 2004, as Susan just mentioned, and we just got through updating that spec. So we're hoping to get this out and begin to start using it again. Next slide, please. So what is the SAMI? Basically, I just told you what it stands for, but it contains about 20% GTR modified asphalt binder. So it's a very heavily modified asphalt binder. Is probably going to grade in the 80, 88 or 90 PG grading based on whatever type of GTR is being used. But it's likely going to be made on site in a blending process. It has to be wet process due to the amount of quantity needed every day. And it's basically a glorified chip seal. So what we'll do is we'll put down about 0.6 gallons per square yard of this material on an existing road and put a 6M graded aggregate, which is typically 1/2 inch to 3/4 inch material, which is basically a modified chip seal. And then what typically goes on top of that, depending on the pavement structure, either a 2-inch or a 4-inch overlay would be put on top to seal it off the SAMI. And what it does is basically mitigate cracking from coming up from bottom up. So the math is a little fuzzy still a little bit, depending on what type of tires are used and what grind process, but it equates to about 180 tires per lane mile. And it really, again, depends on the pounds per tire. And one other advantage of the SAMI is it not necessarily has to be quite as fine of a grind as the typical wet process if you're using it in a dense graded pavement. So that may save a little bit on the upfront cost of the material as well. Next slide, please. So this was mentioned a little bit earlier. This is very, very new to a lot of DOTs and throughout the country. And it's got a lot to do with the new bills that are being coming down from Washington, dealing with environmental product declaration. I think we mentioned this word maybe the first or second meeting what we got together. But basically the DOT, FHWA's ultimate goal is to build sustainable pavements. Oh, can you go back? Thank you. With EPDs, we have to, of course, you mentioned the reduction of greenhouse gases is number one. Methane and fluorinated gases are also measured into that EPD. The infrastructure bills filled with old and new ideas about being more green, which we all want to be more green. And of course, the big thing that's really producing or pushing is the contractors to be more innovative in their production of asphalt mixtures. So that looking at different alternative materials is a big part of that. And as I mentioned before, again, in the previous presentation, NAPA, National Asphalt Pavement Association, developed a program where the contractors can go and establish their own EPDs. The approximate cost of that upfront is about $3,000 per plan if you're a member of NAPA. And it's a pretty painstaking process, at least initially. It takes about 3 or 4 days to collect all the information necessary to do that first EPD, and that's for your plant. So that EPD is tied to the asphalt plant itself. And then once you establish that first EPD for that first mix type, then it's just a matter of moving the percentages around as far as each aggregate type, the percentage of asphalt binders, percentages of recycled materials, rubber, GTR, the list goes on and on. The main thing is RAP is a big contribution to that as far as recyclability. We average about 20 to 22% RAP in a recycled asphalt pavement in our state already. So we're at average or a little bit above already with that. But once that information is put in the system, it takes about 10 or 15 minutes to change or to get a new EPD for each mix type once that initial information is established. So next slide, please. more about this. It just really ultimately is looking at the whole process of production of asphalt mixtures, the cradle to gate approach, the carbon impact of the product from the moment it's produced all the way to the end of life. So it's very, very important to take the considerations in the program of life cycle cost analysis. Different components, I can kind of go through these pretty quick, but materials are a big part. The aggregate, the asphalt binder, the recycled materials, which include RAP, recycled asphalt pavement, the recycled asphalt shingles, the GTR, and more recently, plastics in asphalt is coming on pretty quickly. And a big part of that is the amount of fuel and the amount of carbon production that you're going to generate, even getting the materials to the plant site. So obviously, if the plant site's on location and it's really close to the quarry, then you're going to save a lot on that portion. It's going to be very critical to that EPD number. Production is another thing that to look at. Of course, what kind of fuel you're using is a big driver of that in your asphalt plant, especially if you're using natural gas. This would be a big plus for you. But those of you that are contractors that are possibly using oils, they're obviously going to be a lot worse as far as your EPD. And it's going to be measuring your consumption of drying materials. Production temperature, warm mix asphalt's a big driver of that as well. So that's going to be strongly encouraged to drive that EPD down. And obviously, again, the burner fuel is a big part of it. But driving the CO2s, the no-brainers on this are the stockpile moistures. You know, asphalt, you got to drive the moisture out of your mix to be able to get it to coat and get it to compact. So that's a big driver. Obviously, recycled content, quality of that recycled material in general is a big part. In total binder, this is something that's going to come down to that life cycle cost analysis, having a really, really good grasp on the performance in that balanced mix design procedure that was mentioned earlier. Knowing exactly how much binder you can put in it, you can drop your EPD down to a lower level by reducing that asphalt binder content. But however, that affects your life cycle cost analysis by making a mix that's not going to last or is going to be as durable. So those are options you have to weigh. Again, production temperature as mentioned earlier is going to reduce your fuel consumption of your materials, and that's got a lot to do with your moisture in your mix in general, how much you got to get rid of. And plants insulation, electrical considerations of your motors, those kinds of things, obviously going to affect that that final EPD. Next slide, please. So kind of wrapping up here, advantages and disadvantages of GTR from what we see. Again, our slides kind of got a little bit shuffled around, it looks like in our formatting. Some challenges in the past, GTR, contractors are a little bit skeptical because of their need to get density and compaction in the field. A lot of that's been kind of put to bed over the previous years with experience. The more experienced contractors have, once they get that initial project down, they just understand the process a little bit better, and they're typically easy or get the density required by the DOT or the FHWA specs. Storage issues were mentioned earlier, separation with the wet process. You know, you've got to keep the tanks and the liquids suspended and hot at all times. And typically GTR requires a little bit hotter temperatures, which is kind of a downfall for a lot of the EPDs in a way. But there are some options for warm mix and different things like that that will help with that process. And the continuous mixing to keep that liquid and that rubber suspended in the product in the desired PG grade. As far as dry process, we're still very, very young in those years of looking at dry process. We did our last project in 2020 with open graded, as Susan mentioned earlier. It's more of a mix modifier. It's not a liquid modifier. During the dry process, you typically do not get the temperatures in the asphalt plant to make the rubber and the liquid asphalt become homogeneous. So you're really modifying the mix. So another hurdle is the dry process. We don't have a lot of plants, very, very few plants in the state that can just you can make a phone call and be running rubber modified asphalt tomorrow. They don't have the blending units on site or the capacity to run the dry process rubber. Usually that requires a rental of a unit to be brought in to be able to feed that material. Increased binder content required on most mixtures that require GTR because of that absorption and that expansion, typically in the mix design process, you need to typically add 2 to 3/10 more asphalt binder, which is more costly. That's the most expensive ingredient in the mixture is your liquid asphalt, which today stands at about $650 a liquid ton. GTR modifieds, as far as the binder and the wet process, they can be compared to conventional PMA or polymer modified asphalts on specific specifications, mainly AASHTO 320 and M332. But there are some stipulations as far as separation, solubility, and things that are basically have to be overlooked. Not all doom and gloom. The benefits are, as mentioned earlier, running resistance is generally improved when you run a mix with GTR. Cracking resistance was mentioned earlier. It's one of the reasons why we're looking at the SAMI layer. And the big thing that is a lot of times overlooked is the reduced oxidation due to the amount of carbon black in the tires. And you can see a rubber road versus a conventional pavement. They typically stay blacker for longer, which is more appealing to the eye, but it also makes your pavement markings stand out a lot better as well. So it's a safety aspect, and sometimes they're a little bit quieter, as I mentioned in other research. You see a quieter pavement makes everyone happy. And of course, this number one is sustainable practice, and that's what we're all after, to make a sustainable pavement. And ultimately, we need to collect this life cycle cost analysis to see the benefits. And again, I think that's going to be mentioned a little bit later, maybe with Red's presentation. And of course, those webinars that are going on that were mentioned. There's one on the 8th, which is ended, I think, on Thursday of this week in the afternoon, when I think it'll go in a lot more detail about that benefit. Next slide. Avenues for GTR and asphalt. Of course, our standard grade in South Carolina is a 6422. It's utilized on 90% of our pavements, and that's mainly due to the lower traffic conditions. We don't typically use a higher cost material such as a 7622 on a pavement that doesn't require it, because of that increased cost, that delta cost between the 76 and the 64, which is anywhere from $75 to $150 a liquid ton. That increases. We typically do not need that excess cost for those lower volume roads. But as far as the limited life cycle cost to benefit of using a GTR in some of those lower volume roads, that equates to life cycle cost analysis. So that may be a potential for some grants to be used, especially on county roads, smaller quantity contracts, where we can potentially use those funds. 7622s on your 10% of our roads. That's mainly interstate highways. So anything we got an interstate highway is going to utilize 7622. And right now they can have a polymer SBS modified or GTR. So it is permitted. We just don't see the terminals that are just not relatively offering this product on a day-to-day basis unless a contractor requests a GTR product be made exclusively for them. And again, bringing that back up about the SAMI chip seals, rubber modified asphalt and emulsions are low-hanging fruit, but it is definitely a good time as far as getting that back into our system and start using those again. Next slide. Well, again, we're going to encourage the SAMI process. We're really pushing to get this work done. We got a lot of work to get done. We've got a good opportunity. We got some money in our budget to pay for a lot of roads to get paved based on sales tax increases over the last few years. So we want to get these projects done and completed. So the SAMI process is going to help with that. We need to poll our local contractors. I'll get with Jason Jordan with the South Carolina Pavement Association and see what they feel, what they need to do as far as are they getting on board on getting these EPDs together. I'm sure they are. Are they looking at GTR? Which ones are being encouraged to do so? So we need to do that and find out where they stand on that. And again, the EPDs, some education potentially on those, putting that information together. That might be some grant money potentially for the education and using that for establishing the benefits of using GTR. With that, I'll just appreciate your time. Oh, you want to go back to that slide? I have one or two more little things there. We need more terminals to offer GTR modified products, as is a big downfall right now, and not having enough of them available to show for the wet process. And again, having optional mixes to use that dry process. Having the contractors buy that equipment so they can turn it on and off and make a GTR mix relatively quickly and not have to wait. All right. That's my information, Susan's information, phone number, email address. Feel free to reach out to me if you have any questions or anything moving forward.
Hey,
Thank you.
Cliff, I have a couple of questions if you have
All
a
right.
moment.
Yes, sir. Red.
So what I see, you've done one project in the last 7 years, right? In 2020.
The dry process, yes. That's the last one we did was in 2020 on I-20.
And then the wet process, the last one was in 2015, right?
Correct.
It was in Aiken. Was that a contractor that was from South Carolina, or was that maybe somebody from Georgia?
Yeah, that was on the edge border in Georgia. Yeah, they were already set up to run in Georgia for Georgia DOT. So it was just a matter of flipping switch for them.
Right. So it's possible to have contractors that are willing to do it, but you got to ask for it, right?
Yeah.
I mean, no contractor in South Carolina is going to be doing it because no one's done it in almost 10 years. Like they're not going to set it up themselves if you guys aren't asking for it.
Correct. Or unless there's money to be made, obviously EPDs, different things like that. Hopefully we'll encourage them to do so, to buy that unit.
But they would have to come with a cheaper alternative than what your standard is, right?
Right.
So is there, and that's your kind of constraint on this is, and you talked about life cycle, and I know you guys look at that heavily, but that's not part of the purchasing process, right?
That's correct. That's already determined in the design. So when that project's put out for bid, it's already determined that we want a XYZ mix. And
right.
It's not
so
necessarily a GTR modified.
We're at a point that if that material costs a nickel more, we can't buy it, right?
Right. Yep.
So even if, in theory, I'm just making up numbers, say the regular asphalt lasted 2 years, some other material, rubber or gold or whatever, lasted for 20 years, you can't buy it.
Well, obviously that there's a change order process that could potentially be used. We do encourage value engineering to be used from time to time. And that's where that process, and that's what happened with that particular project in Aiken, was the company approached us about doing a value engineering on several miles of that project on I-20. So we looked at that versus what we typically use with SBS. So that was easier change because we were going from a regular modified binder, which we had, we wanted to put it on a heavy traffic road so it could tell us something.
Right.
Putting a GTR on a road that's got 200 or 300 cars per day is
you're not going to really know.
You're not going to know, and unless the traffic counts and the truck volume increases dramatically, you're not going to see that potential savings.
But you're not going to get a request from one of our typical vendors because they don't know the product. Because they're not asked for the product. We got a chicken or the egg thing going, right?
Yeah. Yeah.
Is there a way that this group could help somehow to, I don't know, make it easier through the State House to not go to the cheapest? I mean, we all know we have our issues with the roads here.
Right.
If there is a time to, let's say, get them to act and make a change that the DOT would want, I would guess it was now after some of the reports that have come out recently on road quality. So I would think that, if you wanted to make a move, I think people in this room could help, and it might be a good timing opportunity.
Yeah. So we definitely be open to those, but it's got to be tied to life cycle cost analysis.
100%.
And environmental. I mean, obviously the environmental thing's a big part. It's a big push right now, and it will continue to be, but it's got to be proven to us that it's going to improve. The upfront cost again is going to pay off in the long term.
Yeah. Yeah, and that's what I'm told. I mean, I work for a tire company. I don't do asphalt for a living. I'm told it's better long term. But if we get some of those studies in front of you and the DOT, I think that I assume that would help.
Right. The problem with that, a lot of that is, obviously the leader, I'd say one of the leaders in the country of using rubber and mixes is in Arizona, and they use 20% and it's mandated there that they have, but they got totally different environmental concerns than we do as far as temperatures and of their asphalt pavements in the summertime. And
but I think Georgia uses a good bit too, correct?
They are on lower, they're not using it on some of their extreme volumes, on like say around the Atlanta area too much, but they are using it. Yeah, they have an option to use dry certain traffic volumes.
This is some good discussion, and I think, Reg, you might be segueing us into that kind of facilitated discussion part of, what do we need to make this practice more common in South Carolina? That's one of the questions we were trying to kind of pose to the group. So I love that you're kind of jumpstarting that. I do want to make sure we're able to kind of get your presentation materials in. Richard, did you have something to add?
Just one sentence, Dr. Clark, there is I believe it's 5% price preference in the Solid Waste Policy Management Act to purchase recycled content products and services. I assume that would apply here, but I don't know, Christy. I mean, that would be something I know that Commerce and DHEC have talked about that, but we'd have to look at it. But I just wanted to share that with Dr. Clark. Not sure that he knew.
Yes, I'm aware of a number of different incentives that are out there, but I think it's been our experience that if you really want this thing to be adopted by the DOTs across the U.S., you've got to show economic performance right now, rather than hoping that you can keep something going on a subsidy from a different governmental agency. That's the road that we've been driving down. That's kind of where we're at right now, and that's what I'll cover here, I think, in my next comments.
That sounds like a good segue. So, Dr. Clark,
yes, I am trying.
Take it away.
Can you hear me first off?
We can totally hear you. I think we just lost some slides. Allie, did you have those slides to share, or?
No, I can get I have the slides. I just want to relocate them again. They've just disappeared on my screen, which seems like we're cursed here.
I have a feeling that the third time's going to be the charm. So let's see if we can get those slides shared, and let us know anything we can do to help.
All right. Well, I'm hoping for the third time is the charm too. Are you seeing my screen right now?
Yep.
Yes.
We see your PowerPoint screen.
Good deal. All right. Let's get started. First off, good morning, Cliff. It's been a while. Glad to see you're still doing well. We've all been struggling with what COVID has done to our travel plans and our operations, and it's good to see at least that we're starting to get back out into the open again. I'd like to amplify a comment that I just made. Look, the environmental side of this is incredibly important. Globally, we're trying to sort out what it costs to use the environment and begin to factor that into all sorts of activities, economic activities. We're not there yet. And Cliff and all of the DOTs, they're operating under some fairly strict guidelines about being economically competitive in whatever they do. So if rubber is going to make its place, rubber not only has to work effectively, it's got to provide the kinds of benefits that are workable within the constructs of the DOTs. That's where we're coming from. That's where we're focused. The presentation I want to cover today, and I'm going to skip through a number of points that have already been touched on, but I'm really going to talk about, what's happening with rubber right now. Where's the cutting edge? What do the economics look like? What do the environmental benefits look like? But how do we make this work? How do we make it function? So with that, let me just again draw a distinction for those that aren't already immersed in this. Wet process, you put it into the binder. Dry process, you put it into the mix while it's being mixed. The results that you get from both of these pavements are substantively similar as long as you're matching the quantity of rubber that you're putting into the mix. Okay, you know, we can argue those points, but that's really in the field what we're seeing. South Carolina tried to put a rubber specification in place, 6-7 years ago, I think, Cliff. I think what's happened is that the economic price of putting rubber into binder, wet process rubber, simply hasn't been able to gain traction in the marketplace. It's not that the pavements aren't going to work if they're managed properly. It's just that the economics don't work. And that's what we learned nationally when the Federal Highway Administration tried to mandate it. The dry process came into being to address the economic and functional shortcomings of the wet process. And it's simply trying to address those. We've got 2 decades worth of field work on the ground now, millions of tons on the ground. Okay, it's in full international and national deployment. We're seeing many, many projects coming on. And in reference to a comment about dense graded versus open graded mixed designs, we're actually seeing the balance begin to swing more towards dense graded. Okay, so you know we've identified the issues that were associated with dense graded systems, and we're performing well in there as well. But the bottom line here is that we've got to show an economic and an environmental advantage, or it really is going to take place and happen in a big way in the industry. So let's talk very quickly about what we're doing and how it kind of ties in with the comments that were already made. We are using a -30 mesh material for exactly the reasons that were just outlined. It blends better with the binder. It interacts faster with the binder, and time is very important in the dry process. We use a chemical modification on these very fine crumb rubber grains to increase binder uptake and to accelerate the interaction that we're seeing in the mix when it's being produced. The materials that are being produced are physically, chemically consistent. You're getting a manufactured product now. It's not a waste product that's being dumped into the mix, which is what we saw in the past. Right now, the work that we're doing is probably the most commonly used dry process rubber used in the United States and in Europe as well. In terms of what the rubber is doing, there have been some comments about the mechanical role that rubber is playing in these mixes. From a cracking standpoint, rubber is blocking and deflecting cracks. It just simply takes longer for cracks to propagate through a rubberized mix. The more rubber you put in, up to about 20 to 25% by weight of virgin binder, the more resistance you're going to have to cracking, and the greater the grade bump that you're going to experience on the rutting side of the equation. I want to show you just a quick visual image of what happens when you put rubber into asphalt. This is a brick of binder, 6422 binder, standard dense grade binder use down in South Carolina and in Georgia. Got a notch put in it. We're pulling it apart to see how long it takes. It takes about 5 seconds to break that down to the bottom. When we look at on the left, we're looking at the base of the notch with polymer. And if you look at the time clock, instead of taking 5 seconds to break, it takes about 4.5 minutes to break that brick apart. So polymers are clearly showing us increasing resistance. If we look over on the right, we see 2 things. Number one, we see the cracking process itself is very different with rubber in it. Compared to polymer, the polymer is showing brittle failure. But if we look at the rubber, we see that it's ductile failure. It's actually tearing. And that is because the rubber is literally intercepting and limiting the propagation of those cracks. That's exactly what we're trying to reach for with rubberized asphalt. As we put more rubber into the mix, the fracture energy, the cracking resistance goes up compared to what we see with polymers. So rubber, again, is mechanically resisting propagation of cracks. And we also know that even in dry mix, the interaction between the rubber and the binder takes a very, very small amount of time, typically 10 or 15 minutes. And we're getting this kind of rutting resistance. You can see with 0%, 5%, and 10% in a dense graded mix, we're seeing that it can significantly improve rutting performance. In addition, again, for those of you skilled in the arts of mix design, ECR is not putting aged binder into the mix. It's not like a wrap where you're stiffening the mix up by putting wrap into it. You're actually putting in an additive that is designed to work both on the rutting and on the cracking side of the equation to improve the performance of the overall mix. Generally speaking, depending on the binder, about a 10% addition of rubber is roughly a 2-grade bump. We are currently in the field in heavy traffic environments, providing up to 5-grade bumps in some of the mixed designs that we're working in. In terms of lab work, it's great to see those interesting things in the lab, but really the performance definitions and proof occur out in the field. And if we take just a quick step through a few projects here to kind of give you a feel for what we're at. We're approaching 10 million tons in service now, both here in the US and in Europe. We've got 21 years of field experience in 13 states. We've got about 10,000 miles of heavy traffic roadway that has used this process. Again, this is no longer an experimental process. The performance characteristics are pretty much known. We're on the NCAT test track with a dense graded mix design. And as you might expect, we've worked in a wide array of climates and with a wide array of mixed designs. If we take a look at heavy traffic roads like I-75 south of Atlanta, this is a heavy traffic environment. We in our very first project in Georgia, we put a thin overlay porous European mix down with a polymer control. The state expected it to last 5 years. It lasted 14. The performance of the rubber was comparable to polymer, and you're going to hear this over and over again in the field. Rubber and polymer are side by side, lasting about the same. Rubber a little bit better, especially in colder climates, but even in fatigue cracking areas, rubber is certainly comparable to polymer in terms of field performance. The key here is rubber is cheaper than polymer, and it's typically $2 to $3, and it can be as much as $10 per mixed ton cheaper. And obviously, these are the kinds of numbers that to get everybody's attention, because that's a big change when you come to the mixed pricing world and low bid world of asphalt on public roads. In Georgia right now, they've got about 1.5 million engineered crumb rubber tons down on the road. And they're not only using it in open graded and SMA projects, they're also using it in dense graded as well. Further north up in Illinois, where they're exposed to extreme traffic loads and extreme temperatures, these roads have been exposed to as much as a week where the temperature has been 35 below zero. In these road systems, you're looking right now at a surface that's an SMA. We've got 51% asphalt binder replacement, 40% wrap, 3% RAS, 10% ECR. And we're bumping a 46-34 binder up to a 70-28 binder with all these additives going into the mix. These SMA highways are performing exceptionally well, comparable or better than wet process rubber, comparable or better than polymer, okay, and at a significant cost savings. I think we're looking at $15 per mixed ton cheaper with the combination of all these technologies in these sorts of roads. Here, as we've mentioned, we've got material down on I-20 near Aiken, and right now it's only been down for a few years. We're seeing comparable performance, possibly a little bit better with the rubberized asphalt, but I think it's early yet. We don't see anything happening here that is different than what we've seen on the other roads that we have in service throughout the U.S. In terms of medium duty pavements, where we're down more towards dense graded mixed designs, we're seeing a lot of success both in cold and in fatigue cracking environments. This just gives you kind of a flavor for some of the work that we've done. 20 different dense graded municipal streets in Michigan, Illinois, and Indiana, up to 15 years service with good bases. And what we're finding is that we're seeing no material running, no material cracking, and we're seeing extension of road life as a result. We're also measuring reduced noise, anywhere from 2 to 10 decibels, depending on the pavement that is being replaced. And again, that's pretty common in the industry. What I'd like to zero in on for just a moment here is a project that we did down in Texas. We laid down a pavement in 2008. This is an overlay on top of cracked and spalling concrete. The previous overlays using standard hot mix would last typically about 10 years before they'd require a mill and a new overlay put on. And instead of putting in a 2-inch overlay, we put in 1-inch thickness of rubber modified asphalt using the dry process and a 1-inch thickness lane using a polymer modified asphalt. We're now here 2022, so we're 14, just heading into 15 years of service on the road. And essentially the Texas DOT is expecting this road is going to last between 25 and 30 years as opposed to the 10 they had been seeing up until now. We're seeing some of the cracks that are propagating up from the joints in the concrete, but they're not opening up in the overlay. And again, this is a reflection of the fact that the rubber is resisting the propagation of cracks over time. And what we see here is part of the key to the economics question that was raised. A thinner pavement is going to be substantially cheaper than a standard thickness pavement. And that's something that we're seeing now popping up more and more across the US and in Europe, is that we can marginally reduce pavement thickness. And basically there is no cost to rubberizing the pavement, and you're still getting equal or better performance out of the roads. We see a similar set of projects in Colombia where we're comparing rubber, polymer, and we're comparing plastic pavements. And right now it looks like the rubber is performing as well as polymer and better than the plastics pavements that were put down. Again, these are thin overlay environments. This is the world headquarters for the American Society of Civil Engineers. They put a sustainable parking lot in to show leadership in the area of sustainable paving and sustainable construction. Everything that you see here before you is made of recycled materials. All of the stone materials, walkways, the planters, curbs, and the asphalt pavement is using dry process ECR. So again, across the board, we're seeing this pop up and being used more and more. From an engineering standpoint in the field, contractors have accepted this technology. We're approaching 200 plants now, I think, with an estimated 10,000 miles plus of road paved. Field engineering's been vetted. The mixed performance has been vetted. It's specified by multiple governmental agencies. We're approaching 10 million tons, I think, this year. We hope to get over that mark. And I would say that we're into the mainstream market now within the paving world, although each state, it may be new and it may take some time to break in. So let's zero in on economics, because I said that is incredibly important. When rubber is incorporated into roads, you're going to get some near-term savings. You're going to get some performance improvements, which extend the life of pavements, and you're going to get some sustainability benefits. And I want to touch on each one very quickly. Generally speaking, depending on the market, we can save anywhere from $3 to $5 over a 1-grade bump for polymer, $2 to $10 for a 2-grade bump, and this depends. It depends on the existing DOT regulations, and it depends on market conditions for polymer. These numbers are all over the ballpark right now because the supply challenges have been so great in different parts of the world. But we do see consistently a meaningful savings when rubber is used in place of polymer. That's typically for your heavy traffic roads. For your lighter duty roads, what we're seeing is we can reduce the thickness of pavement, and as a result, we can offset the cost of rubber and essentially save anywhere from $5 to as much as $20 per ton, with a 50% reduction in overlay thickness as an example. We're seeing benefits from increased recyclables content. We can tolerate more RAP. We can even tolerate some RAS and mixed designs because the rubber is limiting the cracking that would typically come from these materials being added to a mix. And of course, we have plant savings because it's a more simplified operation. One binder tank that can be modified in multiple directions by the addition of rubber and other additives into the mix itself. So these are all areas where we can see some immediate and attractive savings that make rubber a lot more useful for the environment, for the producers that are operating. And again, this is going to depend on the DOT specifications. We know, looking down the road, when we look at life cycle cost, we know that introducing rubber into a mix is going to reduce the amount of maintenance and the speed with which the pavements break down. This is a historic comparison between a 20% rubber content in the binder and a standard hot mix. When you put in 10% dry process rubber, you're going to get a performance that's going to kind of come in between those two, but clearly it's going to show an economic benefit over the long term in the road. We're also seeing a number of other benefits. We're seeing higher skid resistance. We just measured on an interstate about a 15% improvement in skid resistance with the pavement coming in using rubber. We're seeing improved fuel consumption with vehicles, and we're seeing reduced amounts of microplastics production from tires. These are all significant environmental and safety benefits that don't usually get quantified when we look at the low bid cost for use of rubber in a road. We also see noise reduction. I'm not going to spend a lot of time on this. Cliff has already mentioned that they do see quieter results with rubber in roads. We're typically seeing 4 to 8 to 10 decibels is kind of the standard reduction we see when you compare a smooth road to older asphalt. Obviously, if you're putting it over concrete, the improvements can be more significant. Finally, from an environmental standpoint, there are substantial environmental benefits that are seen with rubber. We have a problem in the industry right now, and that is, Cliff brought it up, we're looking at these EPDs, these environmental product declarations, as going from cradle to gate. Well, if we go from cradle to resurrection on these roads, what we're going to find is that some additives are going to extend the life of the road, and the environmental benefits that are associated with the extension of road life really eclipse everything else that you can do in the industry. So although we look here and we see with rubber and road, we can see some significant and very attractive benefits in its own right, we are not seeing the really large benefits that are going to come from extending road life. And I think that as we evolve further down this path, the EPDs are going to be looking more, not just at the ingredient side up to the point where the mix is produced, but they're going to look all the way through to the end of the road. That's going to create a new set of challenges that we're all going to have to deal with. Now, in terms of quality control and quality assurance, Cliff, I know is zeroed in on this as an item of concern. And I would just tell you that what we've done is not terribly different than other mix modifiers. We can identify and we can measure how much material is being put in at any one point in time. We can accurately feed the material into the operations, and then we can come through the back end of the operation and we can look at the mix and we can measure the quantities of additives that are in there. The rubber that we're producing right now, as I mentioned before, is now a specification grade product. It's not garbage that's being dumped into the mix. This is stuff that goes through a whole series of quality control checks for size, cleanliness, moisture content, chemistry. And the specifications that Cliff showed for the North Carolina provisional specification, I think that was created around the I-20 project, do in fact reflect the fact that these products are coming in and they're sized and their cleanliness and their chemical constituents are all included in that specification. We have an ISO compliant manufacturing process. We've got controlled packaging to maintain the quality of the product in the field before it's being used. So we've got that quality taken care of. These feeders, which are becoming more available now, there's some contractors that overlap between Georgia and South Carolina that have the ability to bring in their feeders and begin producing tomorrow. Should you desire to do so in state, and we're working on getting additional feeders put in. And then in terms of post-production modification, we've got the ability to test the mix, much as we would with balanced mix design, but we also have the ability to use an ignition oven to verify contents. So when we look at South Carolina from our perspective, I think that South Carolina DOT is like every other DOT, is being very careful to make sure that they don't just adopt something that's going to cause issues and problems down the road, and they want to be very deliberate in what they do. Our experience has been that everything from SAMIs to full depth replacement, dry process rubber is usable and can be included in your process concepts without any loss in product quality. We've got all kinds of available specifications, which I know South Carolina DOT has already tapped into. We're clearly coming in with both technology enhancement and cost change order options in different states. We are participating in a national feeder build-out program. There are units, as I mentioned a moment ago, that can be brought into South Carolina without any supplemental cost. There is state funding in South Carolina available for one set of counties, I think, based on need. And EPA funding within the past few weeks has become available that can help fund other feeders coming into the state. And that's something that we'll be working on. And we would be happy to work with South Carolina DOT and with DHEC on pursuing that money. And then finally, in terms of statewide training, which again, as already mentioned, we've already begun doing statewide training through the LTAP programs. And EPA has also provided some funding to help develop this market and make things available. So I guess just a few final thoughts. Engineered chrome rubber dry process, it's really a known commodity from an engineering standpoint. It's a question of comfort, I think, on the part of the DOTs as far as working with it. There's a significant broad array of benefits that are available to with the technology. Cliff, you had mentioned compaction, and I think you're correct. Those issues have been pretty much put to bed. We've got 1.5 million tons down on the ground in Georgia and a wide array of mixed designs. It's not the exact same set of operating requirements that you have set up in South Carolina, but the environment and the materials are similar enough that you've got a pretty good idea of what's going to be able to function well inside your system. The support funding is in place to help expand these markets more rapidly if the will is there. The contractors will embrace this, and they'll embrace it because they recognize that they need to not only innovate from an environmental standpoint, but they also need to be cost competitive. And rubber is entering this market because it is cost competitive and it works, not just because it works or because it's environmentally attractive. Okay, we're seeing adoption at the state level happening here in the US and overseas. And the value proposition, which I just touched on a moment ago, is really helping not just the producers and the road owners, but it's also helping the road users, because we can produce a safer road that is going to be durable longer at a lower cost. And I think that ends up being something of benefit to everyone. I'm not going to offer rubber as the solution to all of our problems. It isn't, but it's a significant tool to include in your toolbox, and it's something that we would really recommend. So with that, please feel free to contact me if you have any questions. Thank you for your attention.
And that's just some great information, Red, and all of our speakers today. I think this is a good time to make sure we're kind of thinking through again in that question of what do we really need to make RMA, more common in South Carolina. And I think we've already heard a few of those themes coming out in the presentations today, but are there some things that have jumped out to the group today?
Well, one thing that we can do, and Cliff, I'll make this offer. This is Red Clark. We are actively preparing proposals to provide training and to provide equipment for your contracting community. If that's something that's of interest to you, we'd be more than happy to, participate with you in terms of getting a proposal put together. We're working with multiple DOTs right now to do the same thing, other states. There's about $275 million that's available that can be tapped into. So if you folks are interested, please give me a call, Cliff, and we'll be happy to sit down with you and see what we can work out. Ditto with DHEC, we'd be happy to work with you as well.
Appreciate that, Red. Definitely, we'll reach back out to you. I need to poll the contractors and find out what their needs are. They're just now starting to evaluate and look at their EPDs, and hopefully they'll look at rubber as a option, or again, like a tool in your toolbox to use in where it's needed. Obviously, we got to be smart about the way we do it, and it's got to be tied to life cycle costs.
Cliff, would it be helpful if we produced some kind of a document that you could essentially make available to your contractor base that gives them the ability to integrate some of the benefits, some of the environmental benefits that come with rubber into their overall set of expectations on how to put mixed designs together with EPDs?
Absolutely. Yes. I'd like to get with you about that, come up with some good questions for that poll and find out where they stand on that. Absolutely.
Cliff, I don't mean to make this a private conversation. I'm going overseas shortly in about a week. And I'm going to be, we're turning on a couple of additional countries, their transportation ministries. And then I'm going to be back just before Christmas. So if you have time right after the first of the year, let's try to either get together or at least talk on the phone and see if we can't pull some things together that will help your contractor community.
Perfect. Yep. First of the year is perfect.
So we would all like to go overseas with you as well. We'd love to know the itinerary of that. But short of that, let's go back and kind of revisit that first question that Allie's sharing up there, which is, what is that supply chain for rubber modified asphalt? Are there some supply chain concerns or items that we need to be aware of?
If you're going with dry process rubberized asphalt, contractor access to compliant feeders is it's not a deal killer. It's an expense. Cliff mentioned that if he called up a contractor tomorrow and said, I want you to switch over to rubberized asphalt, they don't have that ability. These are fiber machines. They're not terribly new to the industry. But a number of players in the state don't have them yet. And so for South Carolina, if dry process is going to be an option, clearly that's something that we need to look at. It also strikes me that the supply chain really isn't going to evolve until the DOT is comfortable with a set of options. And again, that's something that I'll certainly commit to working directly with Cliff on, because we've got not just the interstate work and heavy traveled highways. We've also got residential streets, county roads that need a lot of attention. I think the SAMIs are a great idea, and I think you're going to be very happy with the results. But you can also rubberize dense graded mixes, and we understand how to do that. Again, with the swelling issues being properly managed, again, we'd be more than happy to share that experience. South Carolina DOT is going to drive demand. Okay, that the first requirement is it's got to be allowed. And to the extent that South Carolina DOT permits any kind of practice that involves rubber, whether it's wet or dry process, then the next hurdle is going to be economics. Then the next hurdle is going to be equipment. And if the equipment is available, the economics become more competitive, at least on the dry process side of things. So we can kind of work on these concurrently. But in order to make the product available to the road construction industry, first permission, then the ability to deliver the material and cost efficiency are the sequence that we need to understand. There's plenty of rubber. There will always be plenty of rubber, at least for the foreseeable future. At competitive prices. That's not the issue. The issue is going to be clearing the way so that the product can be used.
Again, really great conversation, great information. I know we've got a little bit of time left. I want to make sure we're kind of thinking through this as a group and want to plant some seeds for everybody to be thinking about this in the weeks to come too with the holidays. But how do we use our partnerships to make this more common? I know when we had our first scrap tire meeting, the partnership component was a really big strength of this group. And we've got a lot of different people here in the room today virtually. So do y'all see some ways to use the partnerships to help with this process?
Well, this is John Sharon on the economic side. If South Carolina DOT was able to get some funding through the infrastructure, I'm sorry, through the Inflation Reduction Act or the infrastructure bill, then that would help offset costs. Then you're starting to build an industry and you can get some economies of scale. Of course, a one-off job is almost never going to be cost efficient compared to a production process where the economies of scale are being fully taken advantage of. And we've got an opportunity here with EPA money, I'm sorry, with infrastructure or Inflation Reduction Act money to really build out the supply chain so that you do get economies of scale. I agree with Red that there is ground rubber in the area. Certainly, some of the finest stuff is made right next door in Georgia, and there probably should be ground rubber production in state. But it's not going to happen until there's a market that will demand that crumb rubber. So there was that mention earlier, a little bit of a chicken in an egg, but perhaps some of these federal opportunities can break that open.
John, this is Red. I've heard chicken and egg. We got to start thinking like a rooster, and break the chain. And really, what it comes down to is that where there's a willingness, the materials, the equipment, and the know-how are there. And it's just a question of putting the pieces together. And the rooster part of this is, people that step up and assume, both pavement quality and environmental leadership to make these things happen. The DOTs have a heavy burden of producing good quality, long-lasting roads that are as cost-effective as possible. We think rubber has reached the point now where it can serve that purpose, or help the DOTs achieve that end. So really, it's going to come down to a great deal on exactly what the DOT needs in order to move forward. And I think that what John just said is that there's federal money, there's probably state money, there is in most states, and there's certainly a lot of technical expertise that's available to help move it forward.
I would add that some of the scrap tire programs in Kentucky and Tennessee offer funding down to the county level so that the demonstration projects are being produced and the contractors are getting the experience with the material. Both a couple other hurdles that need to be overcome. And perhaps South Carolina can take a page from those books, and some funding within the scrap tire program could be directed toward market development that could start offsetting cost differential where there would be some.
So Richard and Anna, y'all are hearing some good concepts, good ideas here. Do y'all want to kind of help us think through what those next steps are and where we go from here?
Sure, I can chime in. So we are just really grateful for the conversation today. I think it's timely and really just hit the nail on the head. So I just wanted to thank our presenters. The process from here is we actually don't have a meeting scheduled for January. The plan is we want to, as I think one of our last questions was, look at partnership opportunities. We wanted to reach out to folks individually as partnerships really develop and make sense, to have a few key initiatives coming out of the process that we've had up until now. So for example, we know John Wingus and his team is interested in looking at fees for opportunities to help fund things like market development, and then cover the cost for local governments. So they would be one of those initiative leads. And certainly, you know, we've heard today that that rubberized asphalt is an area that needs some attention. So putting together some folks that can help lead those next steps. We've heard some good discussion today around connecting with the asphalt pavers, putting together a survey, identifying what are some of the barriers to entry, and then how do we tap into those federal funds. So some of that is really going to take boots on the ground and a little bit of a project management focus. So the idea is to have, you know, 2 to 3 initiatives coming out of the fall conversations. So what our plan is to really formulate those pathways, working with some of you all individually, and then give us the marching orders as we move into the spring. And certainly, as we're aware that that the iron is hot, especially when it comes to those federal funds, and making sure that we're looking at those as they're coming out. So we don't have a meeting scheduled for January as of now, but we will probably be in touch with several of you moving forward to make sure that we're putting together some actionable items. But that is what I have. Richard may have some additional thoughts to add. He may not be able to come off of mute, but for all of us, I just want to thank the group for meeting together over the course of the last several months. It's really helpful for us to make sure that we're moving this process forward. And I think that the squeaky wheel is definitely important. It's important for us to really focus on this, and the time is right. So just wanted to thank everybody that's been involved in the conversation as we move forward, and certainly as we continue to play out, putting together some of these initiatives to really make our state flourish when it comes to finding solutions for recycled tires. So not hearing anything from Richard. So with that, I'll hand it back over to you, Christy, to close us out, or we might already be closed. Do you have a final thought, Christy? I think she might be in transit to another meeting as well. But again, thank you all, and we look forward to connecting in the next year, and happy holidays.
Happy holidays. Bye, y'all.
Yep. Thank you for your time.
Bye.
Thank you, guys.
Thanks,
Thank you all.
everyone.